Okay guys, this is the video about troubleshooting the odometer from the Japanese car. This odometer is a dial odometer, that is, it's not digital. And the problem with which I'm having, the problem with it was is that it has stopped working. That is, it stopped rotating. It's like it's stuck. We are going to identify the component associated with this odometer and try to see if we can troubleshoot to fix it. Of course, the one way to fix it to go to junkyard and buy the whole instrument cluster. What you're looking at right now is an instrument cluster with, if you look closely, the odometer is missing. There is a gap under both the speedometer and an RPM meter. And one way to buy the whole cluster for $60–70. I have already pulled out the whole instrument cluster and disassembled it, and taken out the component which are associated with the odometer. Also, it's worth mentioning that all other instruments, for example, the fuel gauge, the temperature gauge, door open indicator, ABS and fuel gauge, and the transmission bulbs and all other instruments seems to be working. So we'll keep in mind, maybe that might help us to pinpoint the problem with this. Here you go guys, this is exactly what instrument cluster look like. In the back of it, I'm going to soon take it apart to put back the odometer. As you see, there is no odometer here. It's empty space. And this is what instrument cluster look like taken apart. And this is how the odometer sits in the cluster. So you see I put it back installed. Okay, so here are the two major components which I have taken out from the instrument cluster, which are directly helping the odometer to work. One is this control card. This control card is housing multiple components. Let me see. One is housing not only the odometer, which is connected, stepper motor is connected to this connector here, 6-pin connector. It is housing speedometer. There is 3, as you see, the holes for the screws, connectors. There's the transmission bulbs, plus there's a fuel gauge here. And it also has a connector with the 22 pins. If you see it clearly, 22 pins in it, which are most of them are the signal lines coming from the sensors in the car or to be used by these components. We are more interested in 3 lines. One is battery voltage 12 volt plus ground, and also VSS signal, which is a signal coming from the vehicle speed sensor, which is a square pulse, a 5-volt square pulse. So later we're going to try to extract those pins out from this socket. We're going to analyze closely what we see in this control card. The second component is the actual odometer, which is not working. Let me put it here. Which is not working. This is a dial, as you see, a dial odometer, and there is gears in it, which is helping the stepper motor to turn. This is a stepper motor, is connected with 1 screw, and there was a rivet. I already drilled it out. As you see, I can try to move it. It seems like it's moving. If you see closely, it's moving the gear when I'm rotating the shaft of the stepper motor, and it's the dial is moving too. See the number? It's moving. So we are not sure what stuff. So major culprit which can cause the odometer not to rotate is, I kind of wrote it down, is probably the gears in this whole frame is slipping. These dial gears are slipping. Another second problem could be the stepper motor is worn out, or there's some problem with the stepper motor that is stuck or sticking. The third is the connectors, the connections in this card, going from this connector pins are somehow are open, are not connected. The control card components, any resistor, capacitor, transistor has gone bad, which is causing the signal. And also maybe there is no VSS signal coming in this card. That can be another problem. We'll try to test all of them one by one to eliminate all stuff. Okay, I already took out the screw from the stepper motor. So we have this total separate. We can check the mechanism of it is by turning this gear, which is turned by this stepper motor. As you see, is moving freely. Though there's no gear slipping, unless the gear connected to the stepper motor is slipping, but all other gears are working fine, and it's very loose, very free. It's not and there's no symptom of it's being stuck. So we'll keep in mind that this should be working fine. This is a unipolar stepper motor. There is a 6-wire, and while I turn it, it has it's not too free. It has little stickiness in it, which could be a problem, but we are not sure unless we test it. There is one easy way to test it is to check that this is a unipolar 6-wire, so we can have little knowledge of the stepper motor. It should have 2 main windings with 3 wires coming out of each winding, in the 2 at the end of the winding plus 1 in the middle. So the resistance, we can check the resistance of the total 2 windings should be total of the resistance of the half of the winding. And we'll see how to test it. I'll show you in a short while. Okay, so we're gonna test the we're gonna try to test the resistance of the winding. Remember, this is a unipolar stepper motor with 6 wires, so we're expecting to find 2 main windings with 3 wires coming out of each, with the resistance between the 2 ends is a total of the resistance between the middle one and the 2 ends. That's what we're expecting, is the total winding should be the twice of the middle wire and the end. Let's see whether I'll be able to explain it correctly. Let's put one point here and check for the resistance. It's showing 166 between these 2 points, extreme points. We're gonna check key 1 is still connected and check the other point, and there's another one which is 166. So this is the half. It seems like it's a half of the total winding which we are seeing. Let's connect to the other point. We should not get any other connection. So now we can find easily that the 2 ends of the winding sits here in these 2 connections. See, is the total of the half total resistance of the winding, and this is the half of the resistance of the winding. So the middle wire is this extreme right, with the extreme right wire which sits in the middle of the particular winding. Let's check the other winding. We'll keep it here and test here. This is the half, and there's nothing here, nothing here. This is half here and half there. So these 2 points should be the total. As you see, is 337 ohms. So the middle of the second winding is sitting here. Right on. That's going to help us to connect these wires windings to the battery, 9 volt or 5 volt, to see whether the motor moves conventionally. Also, I have made some customized wires with the pins, plug-in pins, and with the heat shrink. I don't know whether you're able to see it, with the heat shrink and solder pins, one end male and other end female connection, to help us to extract signals or from the motor or the control card socket. Okay, here you go. I have connected the stepper motor conventionally with 6 volt power supply here, which is coming into this breadboard, 6 volt plus ground. Then, as you know, the unipolar stepper motor look like this. It has 2 windings with 3 wires coming out of it. One in the middle, which are the red wires, which gets 6 volt power supply, and the rest of the end windings will ground them one by one and see if the motor moves. Okay, so here you go. Let me turn on the power, and there is this ground wire I'm gonna use to touch each winding and see if the motor moves. Okay, here you go, it moved. It didn't move. It moved a little bit. So we are not sure whether the motor is okay or not. But then we'll find a motor which is stepper motor. I bought this motor for $2. Which is supposed to be working motor, and we're gonna test this motor whether our test passes. Okay, so I'm gonna connect this the same way and see if this moves, because the one we took out from the odometer is not moving as we expected, but maybe there is some the way we are doing it something wrong. So, but we'll see if I connect this one and see how this moves. Okay, here you go. I have connected the known good unipolar stepper motor the same way as I did with our original stepper motor, and there's a connecting wires. I'm feeding all the 4 phases. Is connected to and the same principle as I mentioned before. The unipolar 6-wire motors have 2 windings, and 3 wires are coming out of each winding. The middle ones are used to is connected to the voltage source, where all other 4s are periodically connected one by one to the ground, and which gonna make energize each half winding and gonna make the motor turn, and the torque will be generated, magnetic field. So here you go. I have this connected like this. I'm supplying supplying ground and 6 volt here, and this is the middle two middle wires of the 2 windings, these red ones, and then I have connected these rest 4 in an open connection, and I'm taking out the ground wire with the pin. This pin is I'm gonna touch each pin, ground each winding ends one by one and see if the motor turns. I'm going to turn on the power supply right now, and here you go, and then we'll see what happens. Okay, I'm going to plan to touch the first ground connection wire, and you see it moving. So this is pretty much a good motor. Our suspect is our motor from the odometer has some issues. Which we are not sure. So that's all. That we proved that the mechanism we are using to differentiate between good motor and bad motor is that this motor didn't work as good as we expected. There's some issues, so we'll figure out what actually is going on.